because you have to protect the database. Before, in the previous time, a long time ago, it was easier because there was only 5250 access and physical cables, twinax. So protecting the access was easy. Now it's not easy anymore. There's FTP, HTTP, ODBC, JDBC, and so on. So it's not that easy to protect. Most of the time it's done by a firewall, an external firewall. But there are also internal consideration to have on the rights, on the authority to the object themselves. And I think Steve have a presentation after mine in the other room this morning about this. So what's the problem? Because IBMI is very stable. It has a very good reputation about this. There's close to no maintenance. The database administrator job did not exist, close to not exist a few years ago on IBMI. And it works alone. It works by itself. And it has a reputation of no viruses, at least now. We should look at this. Maybe there will be some viruses later, but viruses, formal viruses are not known on IBMI now. And the HS solutions prevent from a system outage. So the problem is, in fact, the data deletion. If someone wants to delete some data or corrupt the data or the bugs, and this is what we are looking for. We are looking at today. For example, a new version of a program, any kind of program, it has been tested on the test environment, but some parameters are different on the test environment. And when it's put it in the production system, then a bug is detected, but only a few hours later, because it's not obvious all the time. And many data can be corrupted or changed. And in this case, in some case, it could be very hard to come back, find every record that has been changed, and put back the right version. In this case, you have to take your backups and potentially come back 24 hours ago for your data. Another option is another example, an environment with only one partition where the production, development, and test are on the same partition. I know that's not a good idea, but a lot of companies have only this and still do that. A programmer wants to test a new program and he forgets to change the library list. So he runs his program with the bug or without bugs, but with wrong versions, wrong data on the production partition and on the production libraries. Then potentially again, a lot of data can be corrupted. Again, most of the time, the only option is to come back 24 hours ago. And the last option, the harder, a user that internal to the company, and that will be fired. He's very angry. That's his last day or last week, and he's internal to the company, so he has the access to the database. Let's figure out that he can find a way to create a new user profile, a pirate user profile, and leave no trace that the user profile has been created. On the evening, it uses the clear physical file member command for 2 or 3 tables. In this case, the data from those tables are lost. If one of the table is all the order coming from internet, then those orders are lost. You have really to come back 24 hours ago if there's no journaling option on these tables. Okay, in this case, data deletion is very important, and you lose data, you lose money, you lose credibility. You lose many things, and consistency. High availability, as I said before, does not help, because if a clear physical file member is done on the production system, then it's immediately replicated to the HA system. So it's cleared on both sides. So it doesn't help. So what are the solutions? What can we do? We will go through those three options: the backup, fresh copy or snapshots, and the journals. Let's start with the backups. So backup has to be done at least once per day. Standard backups with standard commands, save library, save for the IFS, etc., with or without BRMS or with any other product, are very stable, and it's easy to use them, but it's time consuming. Most of the time it takes a few hours, and all the users are locked during those backups. So it's necessary, but it's only once a day. And more and more, you don't have the time to run them, because the system must be active for 24 hours. The save while active option. That's a good idea, because at least you have a bigger window for your backups. The save while active is an option included into every system command. So in the save, not the save sys, but in the save library, save object, save for the IFS, save change object, you have these parameters. That's those three. It allows to let the users work while the backup is running, except during the first phase of the backup. The phase one, you have to stop the users and to make sure there's no activity to the database. If you don't do that, there's a risk for some objects not to be saved or not to be consistent in the data. So you could have for some orders, the orders file, you can have the lines, but not the the en-tête in French, not the all the records together if they are in two different tables. So it's necessary to stop the users for the beginning. Here's a schema that explains how it works. I will not go through all the details. You can look at it later. The important part is here. Here is the beginning. So at this point, you start the backup. This is the status of the database at the beginning, and the objects that are in memory. The system will look for a checkpoint. So a checkpoint, it will have to read every single object, and create some internal structure for this checkpoint. And after this, here it will send a message to QC software by default, or to any other message queue that you define, to say that the checkpoint has been reached. When it's done, then you can start the users again. This first phase is not very long, depends on your database and the activity. It could be between, let's say, 3 to 20 minutes. It could be 20 minutes. Most of the time is, let's say, 3 to 10 minutes. But during this phase, there must have no activity on the system. After that, every time there's a change, the system records the changes and will manage to put on the tape the right data. At the end, the result is that here is what is on the tape. On the tape, you have the original data without the changes that have been made here. But on the system, you have the new object with the new value. So this is the important part. You have the original data. And the other important part, no users during this first phase. Here's an example. Well, I would like to add, many people don't do that and let the users work during this first time. They take the risk to have objects not saved or not really consistent. Here is a program where we can use the save while active. That's an example. It works. I tested it. You can see that here in the save library, those parameters are set. This one say that the synchronization will be checked for all the libraries saved, so all them. We don't use QC Opera, but one specific message queue that I created and that I cleared before. And I created a synchronization ID here, saying that there are two synchronization check message that will come. The first for the save library and the second for the save IFS. And we have here the same parameters. This is the first part of the program. Both jobs are submitted to run the backup on two different tapes. Then we will prepare to wait for the synchronization message. We will receive the message from this message queue, and we will count them. And we also will put another limit, say that if it takes more than 10 minutes, then we will start the users anyway. So if there's a problem somewhere, no cartridge or no something, I don't know what, whatever happens, after 10 minutes, we will start the users again. Then we check and wait for the message, so the receive message, and we wait for this message saying, okay, the checkpoint has been reached, and we will count it. And this, we count the time to know if we are too long or not. And at the end, if we waited for more than 10 minutes, we start the users again. If we didn't have the two checkpoint message, we go to wait again. Otherwise, we start the users. So this is a very simple example for running save while active. Again, about the save while active, this makes that we could run several save while active during the day, but you need to have those 10 minutes where you can stop the users. And it's not always possible, but you could have a backup in the evening, another one in the morning, and another one at noon, for example. That's possible. You can have 3 backups during the day. Incremental backup. In most systems, other than IBM I, the incremental backup means we only save what has been changed, so the records that have been changed or the sectors that have been changed. In the IBM I, it's different. To use this, that's a save change object to use, or an option in the save command for the IFS. But in this case, any object, any file with one record changed will be considered as changed and fully saved. So if you have one file, one table with 1 million records, and you change one record, then the whole file will be saved again. So it takes a long time. It's not that easy. If you need to restore, you have to know exactly on what tape it is and what is the last version. So it's not easy to use. So definitely, to me, it's not a good idea to use. So conclusion: it's possible to reduce the downtime with the save while active. It's possible to do several backups during the day, but it's not very easy, and you have to find places to stop the users anyway. So we still have a delay for the corruption of about 24 hours with data lost. Option 2, flash copy or snapshot. In the IBM world, it's called flash copy. In the other world and other constructors, it's called snapshot. It's close to the same. There are some differences, but it's close to the same. What does it do? It's usable on external storage systems. So if you have internal disk, it's not possible. Forget it, or change your hardware. What it does in these storage systems, it takes an instant copy of the production disk. So if you have 5 disks of 1 terabyte, you just make one click or send one CLI command, and 1 second later, you have a copy of your disk. Sure, inside the box, there's no actual copy. Nothing is copied, that's only virtual. But from outside, you have an access to those disks, and they have the data from the exact time where you started it. It works very nice, very fine. There's close to no performance issue. If you have a normal box, normal system, there's no problem with the performances. There's absolutely no impact for the users, and it's possible to do it automatically. You can write the programs. You can find some program examples on internet to do that, and there are tools or products that do it. IBM has one. We have one, so you can come and see us to do that automatically. About the disk space, you don't need to double your disk space. So if you have 5 terabytes on your production system, you don't need to have 5 additional terabytes for this copy. With our experience, using the thin provisioning, for a period of 24 hours, the first 24 hours, you need about 20% of additional disk space. So 1 terabyte if you have 5 terabytes in the original. So in case of corruption of the database, you can say, okay, I can, did I say it before? No, well, mistake. For example, you could take one snapshot every hour. And so you have one copy every hour of your system. If you have corruption in your database, then you can say that, okay, it happened at 8 a.m., at 8:30. So I will take the disk from 8 a.m., associate those disks to another partition, start that partition in manual mode because it's an exact copy of the production. So same name, same IP address, same automatic jobs, etc. And you will look at those at the database, find the right table, and save it and send it back to the production system. So in this case, you only lose half an hour or 1 hour maximum of data. That's better than 24 hours. And in addition, you can take one of those 24 snapshots or flash copy to use them to run your backups. And you could take advantage of this to run a Save 21 every day, because it's done on another partition and you don't have to lock and to lock the users and stop the users. Let's have a look at this example. We have the production system and the disk on the storewise or on the storage system. Then in this case, that's our product, but it could be any product or your tools, your internal development. We first configure the flash copy. So that's only a structure to create, and configure on the HMC a new clone partition that we don't start at this time. Then when you want, you use one command. This is our, but it could be a call to your program that will first copy the memory to the disk. That's a system command, the change ASP act command that you can use. This command will take every active data in the memory and copy it to the disk. So you have something stable. There are two parameters. One is suspend, and this freezes the jobs from the users. But the other one is force write. And with force write, there's absolutely no impact for the users. It does not do exactly the same, but most of the time, it's a very acceptable result. So you can do it at any time. Then we start the flash copy on the disk bay, on the disk system. So we start, those disks are the exact copy as from those, and we can use them instantly, 1 second later. And they don't use space. The space is growing during the day with only the changes made one side or the other one. With this, you don't just have to start the clone partition, change the configuration, because you have the same IP address and many things are exactly the same. So you have to take care of TCP/IP, schedule jobs, tape drive resources, etc. Make sure that the user subsystem don't start. So there's some specific startup program to do. And then you can run the backup on your existing infrastructure with BRMS or without BRMS or with anything else, or run a Safe21. Don't forget to send back information to the clone to the production system, some logs, messages, etc. If you use BRMS, the QUser BRM library has to be saved here, sent back to the production, and restore here. If you want to do that yourself, it's well documented in the IBM BRMS product documentation. Then we can stop this partition. When it's done, well, this is for the backup, so the one from midnight, for example. But then you can continue to create new snapshots and new flash copy at 9, 10, 11, once every hour. So you have your protection and you have one backup in addition. Okay, next, journals. What can we do with the journals? First, one word to explain what it is. Let's imagine that I have two files, PF1 and PF2, and I want them to be journal. This is a traditional development, a node, a legacy development, for example. If I want to have them journaled, I will create a receiver with this command. Then I will create a journal and associate this journal to the receiver. And then I will start journaling for those two files. With this command, I can say that I want that the journalization is starting for those files or for all the files of one library. Okay, when this is done, every change I made in one file will be recorded to the receiver. In this case, in the receiver, I have the information that it comes from PF1, the record number 3. I added one record and I have every text, every content of the record.
Pascal, and you have 10 minutes left.
Okay. And in this, I will add a second record from the PF2, etc. So every time I change something, I add something, it's recorded here. If I change, because I made an error here, I lost some words, I have the information that it's changed. A receiver is not a file, but it's an object with a limit size, a size limit. So I can create a new receiver, or I can have the system to generate another one. And this, the system generates a receiver 2 associated to the journal, and the receiver 1 is there. I can use it later. Okay, this is fully integrated to the system and to DB2. It's really a system option. There are commands to start the journaling. We can journal tables or files, data area, data queue, access path also, and the IFS, because you can change data in the files in the IFS. There's no need to change the program. Many people think that they need to change the program and they cannot do it by themselves. That's wrong. You don't need to change the programs. You have to change the program if you want to use the commitment control. So inside the program, take advantage of this and put a rollback or validate some operations. Otherwise, you don't have to change the programs. The two modes, that's after only. So I already talked about this. That's when you start the journalization. With the after only image, you can look at what happened, have the history of the changes, and reapply. So restore an old version of your file and reapply all the changes with the apply journal change command. The second option is both. So you have an image before and an image after. It takes twice the place in the receiver, but then you also can use the remove journal change and say, I want to roll back. I want to come back to this time or whatever you want. But it's not always possible. For example, the clear PFM, clear physical file member, only adds one record, one entry in the receiver to say, I cleared. That's all, nothing else. Then you cannot roll back with this. And we've seen that for a pirate, it could be its best option. So in case of corruption, you restore the files, or the file. You have to analyze where the corruption has started, and that's the hardest part of the process. For this, you have to look at the display journal. So if you plan to do that technique, it's better that you train and that you look before to have a crash. That's the important part. And then apply and from the last save to this entry. So this entry number you will find in the display journal. It must be done on the original library. You cannot have a production library which name is X, restore the old version in the library Y and reapply the changes in the library Y. You have to do it in X library. And if you have to do it in the production partition, it's a lot of stress because you change the data. Another issue is to keep the journal receivers long enough. Most of the time they are deleted before, sometimes automatically by by Mimics, for example, by the HA options. And don't forget the other servers, because most of the time now, there's not only the IBMI, there are EDI options, other systems that are talking together. So you have to have data synchronized and the same options on the other servers. Okay, let's go through the case studies. I will try to do it very fast. The first one is one system, no HA solution. So if there's a crash, you lose the system and you lose the data from the day. So if you have stock movements or internet connections, internet orders, then you lose them. What happens in this case? You have the server with the IBMI partition, system, objects, database, and the journals. You have the system backups, you have the daily backups on tape. And what you could do is take the receivers and automatically detach the receivers every n minutes and send them outside. So you save them to a safe file and you send them to an FTP server or NFS or any kind of external server. This could be replicated to a remote site. This is not very expensive. So it's less expensive than having a second power system and in a second secured room. So the situation is that you have your original data and you have your journals. In case of disaster, you get an emergency, a second system. You restore your system and object, you restore your latest database, and you re-import the journal receivers, and then you can reapply the data until the crash. So you have a kind of cheap HA solution. The RTO is still very long, but the RPO is very good. The case two partition with HA solutions. So you have two systems, one production and one HA system, software or hardware replication, any kind. In case of system crash, then you immediately can start on the HA system. So you start again and you don't lose any data, just a few minutes, and you don't lose time. So in this case, it's very, very nice, very good. In case of data corruption, if someone cleared the file, then you lose the original data and you lose the data on the HA system because the replication has been done immediately. So what you have to do is to restore the tables from the last backup, and you lose 24 hours. What you could do is look at connect to your HA system. So you still have two systems, and restore the old version of the corrupted file and apply the changes because you are supposed to have the journals there, and reapply them on the HA system. That's less stress to do it there. Case number 3 is to combine everything. I guess I will not have the time to go through all the case, but let's start. You have your production system with your disk here. We automatically detach the journals like we've seen before. In addition, we create the flash copy structure. And with this flash copy structure, you can use it to run the backup. When the backup is finished, you keep the partition alive and you import the journals. So you have the data from midnight, for example, and every journal from the day are stored here. In case of corruption of data on the production system, a few tables, for example, or the whole database, then you connect to the clone partition, you reapply the data until the exact time of the corruption, and then you just have to save the tables and send them to the production system. It's faster, and you just change a few tables. And it was not directly on the production system, so less stress. If it was the database that was corrupted, then you can reverse the role and start the production on the clone system. So that's, you need some infrastructure for this, but it's not very hard to do and to configure. Okay, finally I did it in the time. Here you have our coordinate, and you can send us a mail or call us. If you prefer to speak German, we have a German speaking living in Austria. I guess you prefer in English. Okay, and we are an independent vendor. We have those three products, and we are present in this exposition, so you can come and see our booth, our virtual booth.